In this video, we are going to discuss the difference between the change in something and the rate of change of something. Now, because this is a physics course and specifically a mechanics-based physics course, we're going to be dealing a lot with objects moving. In order to describe the motion of something, we're often looking at two different points in the motion. So some point we defined as the initial one and some point we define as the final one. Doesn't necessarily mean the object stopped or started moving at those particular points, but that's where we enter the problem and exit the problem. So earlier in a video, I would have discussed the idea that displacement is the change in position. So we learned that displacement is defined as we're going to take position final minus position initial. So if we're at the 0 position initially, and then we are 10 meters away from that initial position, we would say our displacement is 10 meters because we're taking 10 meters minus 0. So you're taking your final position minus your initial position. And we could do this with any quantity. If we wanted to find the change in temperature, so between yesterday and today, we could say that the change in temperature final minus temperature initial. So I'm recording this during summer. So I would say yesterday was 76 degrees, today is 80 degrees. So our change in temperature is 4 degrees Fahrenheit. So when we talk about the change in something, we're just looking at a final and an initial position and subtracting them. Now, when we start talking about the rate of change, we start looking at what is actually causing this final and initial position to be different. Now, the rate of change is the change in something divided by the change in time. The numerator is going to depend upon what you're trying to find the rate of change of. So we're going to see anything from displacement, which you've already should have seen in an earlier video, to energy. We're going to have all sorts of quantity throughout the semester that goes in the numerator of this fraction. So we're trying to find the rate at which something changes. So what you're trying to find the rate at which something changes goes in your numerator. And it's always going to be divided by the change in time. No matter what we do, time is going to progress forward. So we tend to benchmark things in terms of time. So when we want to know the rate of change of our displacement, so I use the example of here of our final position being 10 meters, and we started at 0 meters, so our displacement is 10. So if we did 10 meters in 10 seconds, so our rate of change is going to be our displacement number over time. So if we take 10 meters divided by 10 seconds, that's going to equal 1 meter per second. So after 1 second, you're going to have gone 1 meter. Then 1 second later, you're at 2 meters. Another second, you're 3 meters. So there's going to be 1 second in between each of these steps. So it's telling you the rate at which your displacement is changing. So let me write this fraction a little bit differently. So this is how much change? So 1 meter. This is and how long. Now, because we use SI units, that how long is often going to be understood to be within 1 second. So we're doing 1 meter every 1 second. If these numbers had been different, you would get a different number when you divide it, and that would be your rate of change. Now, we have a special vocabulary word for this, and we called this velocity. So the rate at which your displacement changes is called the velocity. Now, I want to point out a couple of special cases here. First off, if the rate of change is 0, the change will be 0. So what does that mean? So if we look at the idea that velocity equals the change in displacement over the change in time, if I plug in 0 for velocity and rearrange, so we multiply delta t to both sides, we still get 0. Delta d equals 0. Our displacement is 0, so rather than moving, you're just standing in one particular position. And we can do this the other way around. So if we start again with our displacement over time equals velocity, if I plug in 0 for the displacement, anything divided by 0 is still 0, our velocity is 0. So when the change of something is 0, our value remains constant. So when our velocity is 0, our displacement remains constant. So whatever position we're at, we're sticking at it. Or if we're staying in the same spot, that tells us our velocity is 0. And we can carry this on to acceleration that we learned about earlier, where if our acceleration is 0, it tells me my velocity doesn't change. My velocity doesn't change, that tells me my acceleration is 0. The other thing I want to talk about is a constant rate of change versus a non-constant rate of change. So what I've described here is a constant rate of change. So every 1 second, we go 1 meter forward. Well, what happens if it's a non-constant rate of change? All right, so remember up here, this describes a constant rate of change. But if we go from our 0 position to 1 meter, to 2 meters, to 3 meters, let's say this takes 1 second, but this takes 4 seconds, but this takes 6 seconds. So here, we're doing 1 minus 0 over 1 second, giving us 1. But in the next step, we're going from 1 meter to 2 meters, so we're going to take 2 minus 1. But we're doing that within 4 seconds. So that's going to be 1/4 meters per second. So each second, we're not changing the same amount, or every 1 meter, it's taking a different amount of time to make that progression. So while we still have a change in displacement, the change in displacement does not happen in equal increments. So a constant rate of change is a lot easier to work with because it's predictable. If I know 4 seconds have elapsed, I know I've moved 4 meters forward. But for a non-constant rate of change, I know that change is happening. I'm moving forward because I have velocity, but I have no way of predicting the future with that. So you're going to find as we progress through the semester, we're going to be doing our best to stay in realms where rates of change are constant so that our results are a lot more predictable, so that we can say so many seconds in the future what exactly is going on.